everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11 part 1. This is your class 15. Before this we had done your unit 1, which is your physical world. This is your 15th class and we'll continue with unit 2, which is units and measurement, even though which we had started in the last sessions as well. Wherein this we had even though completed your 13th questions in terms of this unit. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. So in today's class we will start continuing with the dimensions of physical quantities, and the last we talk about is your rules for determining the uncertainty in the results of arithmetic calculation, where the three rules we even though had discussed about it. So we go for it and just find out the solution for the same. The topic that we'll discuss is dimensions of physical quantities.
छोटी बांध दे ऐसे ही पसंद अच्छा
Dimensions of physical quantities. So here in that, the nature of a physical quantity is described by its dimensions, and all the physical quantities that has been represented by derived units that can be expressed in terms of some combinations of 7 fundamental or base units. We should call these base quantities as 7 dimensions of the physical world, which are denoted with the square brackets, and thus the length of the dimensions is been representing in a square bracket a capital L, mass has been representing in a square bracket capital M, time is representing within the square bracket capital T, electric current is been denoted by the square bracket within square bracket the capital A, and thermodynamic temperature is being within square bracket, it is being representing by K capital K. Luminous intensity, it has been representing in the square bracket, that is small d and small cd, and the amount of the substance is been also been representing in this within a square bracket, that is as m mole. So the dimension of a physical quantity are the powers or exponents to which the base quantities are raised to represent that quantity. So we will just go for the same and we'll write it down so that you will be able to know. So the dimensions of a physical quantity are the powers that is or exponents to which the base quantity are raised to represent that quantity. Which has been raised, you have to know that using the square bracket that is around a quantity, that means that we are dealing with the dimensions of the quantity, and the square bracket is being representing like this. So in the same way, in a mechanics and all the physical quantities that can be written in the terms of the dimensions, like your capital L, capital M, capital T. For example, for the volume that is being occupied of the object, that is expressed as the product of length breadth and height. So or 3, hence the dimensions of volume are, which will be in the form like volume will be like L and 2, you know very well that is in L cube. So all the dimensions in the, which is L cube equals to that we have. As the volume is independent of mass and time, so it is said to be possesses 0 dimensions in m naught, m0, that is 0 dimensions in t0, and 3 dimensions in length as well. You can say that similarly the force as a product of the mass and the acceleration that can be expressed, we can just write it down. Force equals to mass into acceleration, which is equals to mass into length upon time square. So the dimensions of force were dimensions of force equals to L T square, which is equals to MLT square. Okay, this is in the, these were the dimensions. Thus the force has 1 dimensions in mass, 1 dimensions in length, and minus 2 dimensions that we have, because it will be the minus 2. So it will the minus 2 dimensions we have for in time, and the dimensions in all other base quantities are 0. So note that in this type of representations the magnitudes are not considered. It is the quality of the type of physical quantity that enters, thus a change in velocity, initial velocity, average velocity, final velocity, and the speeds are all equivalent in the context, since all three quantities that can be expressed as length by time, the dimensions will be L by time, LT inverse as well. So we talk about the dimensions formula and dimensional equation. So we'll discuss dimensional formula. And dimensional equation. In terms of dimensional formula and the dimensional equation, here the expression which shows how and which of the base quantity represent the dimensions of the physical quantity is called the dimensional formula of the given physical quantity. For example, the dimensional formula of the volume is m0, L3 and t0, and that of the speed or the velocity is m0, L, t inverse. Similarly, m0 lt inverse square that we have is the dimensional formula for the acceleration, and an equation that is obtained by equating a physical quantity with the dimensions formula is called the dimensional equation that you of the physical quantity. So just I write it down for you so that you can copy it down and you can just easily learn all these things if you are new to it. An equation obtained by equating a physical quantity with its dimensional formula is called the dimensional equation of the physical quantity. Now we go further, that we'll discuss about it. So thus the dimension equations were the equation which represent the dimensions of the physical quantity in terms of the base quantities. For example, the dimensional equations of volume, that has been representing in the square bracket V. Speed is small v and force is F, so that the equation that mass is being representing, that may be expressed in the form. So we'll just write it down. So with the same case we go for here, and that will find it out. So here we go. So for volume it is M0 L3 T0. For speed M0 L T inverse. For force M L T inverse square. And now for density it is M L inverse cube T0. Here the dimensional equation that can be obtained from the equation representing the relation between the physical quantities. The dimensional formula of a large number and a wide variety of physical quantities derived from the equation representing the relationship among other physical quantities and expressed in the terms of base quantities, that is given in the appendix. We'll discuss in 9, and for your guidance and ready to reference we'll discuss that. Now we'll talk about another topic, which is being the dimensional analysis and its application. So here we have sub parts as well, so we'll discuss that in the detail too. Dimensional analysis and its application. So in dimension analysis and its application we talk here, in that the recognition of the concepts of dimensions which guide the descriptions of physical behavior is of basic importance, and as only those physical quantities that can be added or subtracted which have the same dimensions. Through understanding of dimensional analysis that help us in deducing the certain relation among different physical quantities and checking the derivations as well, accuracy and the dimensional consistency or the homogeneity of the various mathematical expression. When magnitudes of two or more physical quantities are multiplied, their units should be treated in the same manner as ordinary algebraic symbols. We can cancel identical units in the numerator and denominator. The same is true for the dimensions of physical quantity. Similarly, the physical quantities represented by symbols on both sides of mathematical equation must have the same dimensions as well. Now we talk for the subdivisions here. So the dimensions analysis and its application. The first one is to checking the dimension consistency of equation. We go for the same. The first part for the same is your checking the dimensional consistency of equation. So in terms of this, that the magnitudes of physical quantities that may be added together or subtracted from one another only if they have the same dimensions. In another word, we can add or subtract similar physical quantities. Thus, velocity cannot be added to the force, or an electric current, it cannot be subtracted from the thermodynamic temperature. The simple principle that called the principle of homogeneity of dimensions in an equation is extremely useful in checking the correctness or an equation of an equation, and if the dimensions of all the terms are not same, the equation is wrong, and hence we derive an expression for the length or a distance of an object regardless of that symbol that appearing in the original mathematical relation when all the individual dimensions are simplified, where the remaining dimensions must be that of length. Similarly, if we derive an equation of speed, dimensions of the both side of the equation when we simplified must be of length by time, which is LT inverse, or LT inverse we can written that. Dimensions are the customarily used for the preliminary test for the consistency of and correctness of the equation, and however the dimensions consistency does not guarantee or of dimensionless quantities or functions. The argument of spatial functions such as the trigonometric, logarithmic, and exponential function must be dimensionless, where a pure number of ratio of similar physical quantities such as angle as the ratio, length by length, refractive index is the ratio, speed of light in vacuum by speed of light in medium, etc., that has no different dimensions. Now we can test the dimensional consistency or homogeneity of the equation, which is in the form of like x equals to x0 plus v0 t plus 1 by 2 at square. For the distance x traveled by a particle or a ball in time t, which starts at a v0 at the time t0, here that is and has a uniform accelerations along, and as well as that along with the directions of the motions here, with the dimensions of each of the term that may be written here, which will be denoted as x will be in terms of that is equals to L, x naught is equals to L, where v naught t or v0 t is equals to LT inverse, and t, which is of course t inverse, and t is cancelled, and that is L will be remained. And for half AT square, it will be LT square, t inverse square, and t square. So t square and t inverse square will cancel, it will also give you L. Okay, so as each term on the right hand side of the equation has the same dimensions, namely of length, which is of the same dimensions that is left hand side of the equation, and hence this equation is dimensionally correct equation. It may be noted that the test of the consistency of the dimension tell us no more and no less the test of consistency of the units, but has the advantages that we need not commit ourselves to a particular choice of unit, and we need to worry about the convergence among the multiples and the sub-multiples of the units. It may be borne in mind that if an equation follows this consistency test, it proved wrong, but if it passes, it is not proved right. Thus, a dimensionally correct equation need not be actually an exact correct equation, but a dimensionally wrong, incorrect, or inconsistent equation must be wrong. That what it want to states that. So I just write it down for you so that you will be able to know about that what we have to say. So I just write it down here. If an equation follows this consistency, if an equation follows this consistency test, it is proved wrong. But if it passes, it is not proved right. Thus, a dimensionally correct equation need not be actually an exact correct equation, but a dimensionally wrong. Which is incorrect or inconsistent equation must be wrong. Now we go for the question that we talk here. So the question we have here as follows, which has been the question is as follows. Let the consider an equation half mv square equals to mgh, where m is the mass of the body, v its velocity, g is the acceleration due to the gravity, and h is the height. Check whether the equation is dimensionally correct or not. So we go for it. First we go for the question. So let us consider an equation which is half mv square equals to mgh, where m is the mass of the body, v its velocity, and g is the gravity. G is the acceleration, due to gravity, and h is the height. Check whether the equation is dimensionally correct. Now we go for it. So here we go. That is the solution for the same. The dimension of left hand side are, which is m l t inverse square equals to m l square t square, so which will give you m l square t inverse square. Now the dimensions of right hand side are m l t square m l t inverse square l equals to m l square t square, which will be give you m l square t inverse square. So the dimensions of left hand side and the right hand side are the same, and hence the equation is dimensionally correct. Now we go for the next question. That will be the 16th question of the session. This has been the 15th one. So we talk about the 16th question. The question we have, the SI unit of inertia is J equals to kg m square second inverse square. That of speed V is m meter second inverse, and of acceleration A is m meter second square inverse. Which of the formula for the kinetic energy K given below that can you rule out to the basic dimensions argument, where m stands for the mass of the body? So there were the options were k equals to m square v square, k equals to half mv square, k equals to ma, k equals to 3 by 16 mv square, k equals to 1 by 2 mv square plus ma. So that's what you have to answer it out. We'll just go for it and we'll find out this. So let's go for the question here. But here we'll be continuing this question in the next coming class, so that it will be helpful for you as well to solve it out, and we'll find out that as well. So here we're gonna end up with this. And other than physics, we had done your chemistry part 1, and chemistry part 2 we are dealing with the redox reaction for class 11th, and other than that we are dealing with the computer based numerical and statistical technique, and we are dealing with the database management and system there, where we had done your ER diagrams. We are dealing with English vocabulary as well. We had completed your reasoning, where we had completed your verbal reasoning and the non-verbal reasoning. In terms of quantitative aptitude, we had started with arithmetical ability. In that we had done 14th topic, and we are continuing with the 15th topic here as well. And that is the another, after completing this arithmetical ability, we'll start discussing about the data interpretation as well. Coming towards your physics part, so here yes, we had done your unit 1, where in that we had done your part 1. Unit 1 is your physical world, and in the same way for the physical world, where we had done what is physics, scope and excitement of physics, physics, technology and society, fundamental forces in nature, nature of physical laws. In terms of chapter 2, which we are dealing here, is your units and measurement, where we had done your introduction, the international systems of the units, measurements of length, measurements of mass, measurement of time, accuracy, precision, and instruments and the errors in the measurement, significant figures, as well as we are dealing with dimensions of physical quantities, dimensions formulas, and the dimension equation that we had started with, and dimension analysis and its application we have started. We will surely be ending up with this unit soon, and we'll start discussing about unit 3, which is your motion in a straight line, unit 4 dimensions in a plane, unit 5 is your laws of motion, unit 6 is work, energy and power, unit 7 system of particles and rotational motion, unit 8 is gravitational. So stay tuned with us. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.